Happy Tuesday, everybody. So we're going to talk about exponential equations today, which will allow you to finish the part 1 homework. But before we start talking about exponential equations, a student sent me a problem that I want to do in class. It's a good problem to do. And so anyways, it's from your homework. I'm going to go ahead and do it, and then we'll talk about exponential equations. So just quickly here, this is a logarithmic equation. So it's log x plus log of x plus 21 is equal to 2. So for this one, this is going to be one where we combine everything together and then we rewrite the exponential, rewrite the logarithm as an exponential. So I'm going to combine these guys together using multiplication on the inside. So we have x times x plus 21 is equal to 2. Now here's where things are a little strange, because when we've done this before, as seen by where's one? It's form B. All right. When we've done these before, where it was form B, where you have like a 1 on one side, and then you have a number on one side and a logarithm on the other, start at the base across the equals back again, right? Which there was a base to start at. But if you look at this problem here, there's no base written. So if there's no base explicitly written, what base is the logarithm? It'll be base 10. Yes, absolutely. So this is base, make myself a little more room in here. Scoot it over a tiny bit. This is base 10, because if there's no base written, it'll be base 10. So start at the base, across the equals, back again. Rewriting this, we'll have 10 raised to the second power is equal to x times x plus 21. 10 squared is 100. X times x is x squared. X times 21 plus 21x. This is going to be a quadratic, so we want to get everything on one side. I'm just going to go ahead and move the 100 over by subtracting 100 on both sides. And then we need to factor this. I'm going to rewrite the factorization on the left side, because I'd rather it be the factorization equal to 0 rather than 0 equal to the factorization, just stylistically. The two numbers that are going to multiply to negative 100 and add to positive 21, it's going to be 25 and negative 4. So x plus 25, x minus 4 equal to 0. We get x equal to negative 25, x equal to 4. And now we're going to check both of those in this original equation. So we need to check it in x and in x plus 21. So if we look at negative 25, we can kind of see right away that that's going to be an issue, because if you plug it in for x, you get a negative. So negative 25 is a no-go. Let's try x equal to 4. 4 works, and then 4 plus 21 is 25, which is also positive, so that works. So we get 4 as an answer. Oh, and I need to change my answer box colors, but there we go. Beautiful. Yay! Does that make sense to everybody? This can also happen, by the way, with ln. All right, you could also end up with a situation like this with ln. Where's all my awful notes? Not that one, not that one. Why can't I just have a nice organized desk? Real quickly, because you can see this happen with Like I said, you can see this happen with ln's. What was I doing? So if you had something like this, 7 plus 15 ln x equals 2, you want to get that ln by itself, so you could start by subtracting 7 on both sides, right? Minus 7 on both sides. You get 15 ln x equal to -5. Divide both sides by 15 to get that ln x alone. You get ln x equal to -1/3 once you simplify. And then this one also is a form B. It's in form B right now. And this might look a little bit like how do you do the loop-de-loo? Where's the loop-de-loo? How do you loop-de-loo it? And that's where it's important to know that ln x is the same thing as log base e of x. So you could just kind of put like a base e in here. And you would start at the base across the equals back again. And you'd get e raised to the -1/3 is equal to x. And I'll just tell you that is a positive number. So it'll end up working. But yeah, something I had to figure out during yesterday's homework. Yeah, so it's one thing I didn't explicitly state, and in my notes in the future, I'll make sure I explicitly do a problem like that where you have to remember the two special cases where the bases aren't written down below. But there's that. There it is. Any questions on that? It's understandable. No problem. I am happy that we were able to do this problem. And you are always welcome, everybody, to send problems that you're having, especially if you're working on the homework from the previous day's lecture. If you're working on the homework from the previous day's lecture and you can send it to me before class, that makes a really good like segue into so we can like kind of recap the previous lecture and then go into the new stuff. So I appreciate it. Okay. So choose a number. I'm not going to show the palette. The number between 1 and 16. Number between 1 and 16. Oh man, there's 13, 8, 10. Oh man. Oh gosh. Okay. Oh man. All right. 13 was the first one that came in. I'm going to take 13. So I'm going to do 13 on, wait, that's not 13. That one's 13. 13 on that palette. And then I'm going to do 13 on, well, that's not a very fun one on this palette. What about 8? I'll do 8 on this palette. All right. Exponential. I was going to do like number 13 on both palettes if it had turned out. Okay. Exponential equations. All right, this is where we're kind of going to mirror yesterday's lecture. We're going to talk about some fun facts about exponential equations. We're going to talk about a procedure for exponential equations, which I'm going to change from what I have written in my lecture notes because I don't feel like it went over super well in my first class. But that's okay. I'm great at improving. Works a lot better when you don't tell people you're improving, though. I'll tell you that much. All right. Just writing this down. So some fun, important facts about exponential equations. Here's the big one, right? So a logarithmic equation is a logarithmic equation because it has logarithms in it. And because it has logarithms in it, we had domain restrictions because logarithms have domain restrictions. Exponential equations are going to be equations that have exponentials in them. And exponential functions do not have any domain restrictions. So we do not need to check our answers for exponential equations the way that we had to do with logarithmic equations. So that's nice. We don't have to actually check our answers to make sure that they don't cause a domain issue. With exponential equations, you don't have to worry about that. Exponential functions. So that's cool. That's cool. That's fun. It's exciting. It's important. 2. If m is equal to n, then log base b of m is equal to log base b of n. And you might say, like, we got that rule yesterday, and you would be close. But the rule that we got yesterday was actually the opposite direction of this. It was, if this is true, if you log base b of m is equal to log base b of n, that means that the insides are equal. This is the reverse direction of it, saying if two things are equal, you can essentially take the log of both sides. This is going to come in handy. It's going to come in very handy. And you can take the log, or you can take the ln. You can take whatever you'd like. Log base, whatever, of both sides of an equation. Sort of like in the same way that you could subtract something from both sides of an equation, or you could multiply both sides of an equation by the same number. In that same respect, you can take the log of both sides of an equation. This next one, number 3 here, this is something we've already gone over. I am just bringing it back into your working memory. If we have log base b of b raised to the x, this is equal to x. So the special cases, if you have log of 10 raised to the x, this is x, because log is base 10. If you have ln of e raised to the x, this is x, because log is base e. Or sorry, no, ln is base e. And you could use a number, right, too. Log base 3 of 3 raised to the x is x. A special case of this is when x is 1. So if you have log base b of b, log base b of b is 1. So log of 10 is 1. ln of e is 1. Log base 5 of 5 is 1. Again, rules we already have, things we've already seen, but we're just going to repeat it. Last piece of fun information. if b to the m is equal to b to the n, then m is equal to n. i.e., if you have the same base on both sides, you can just set their exponents equal and solve. And then that's that. So these are our fun, exciting facts. I know it takes a moment to write stuff down, so I'll give you a moment. We're going to use all these facts today. They're all important. I honestly think, so here's how I feel about like the difficulty difference between logarithms and exponentials. I think that logarithms can be more tricky in that you need to remember a lot of logarithm rules in order to do a lot of logarithm equations. You need to, be able to combine them together, bring up the exponents, rewrite a logarithm as an exponential. It requires you knowing a lot about logs. For exponential equations, what you're going to find out is like you basically need like one fact about logarithms, and the rest of it is just algebra. So the algebra can be a lot messier on these exponential equations, but it requires a lot less knowledge of logarithms, which might make it seem easier. You'll find out whether you find it easier or if you think logarithms are easier after today. Actually, I'd be interested in that. I should start asking students. Maybe I'll ask you guys like tomorrow, once you've done both assignments, to see which one you think is easier. All right. Procedure for solving exponential equations. This is what I'm going to do a little bit differently than I did in my last class. Okay. So your first step, when you have an exponential equation, you're looking to simplify your equation into a form where you have like a base on one side and a base on the other. That's the goal at first. Sorry, just got an email from our department chair. I wonder if apparently some kind of fraud email got sent out. Oh, well. So you want to get it into the form where you have like b raised to the whatever is equal to c raised to the whatever. That is the goal. You want it in this form. There's two things that can happen from here. Right? Two things that can happen from here. One, b and c can share a common base. Right? So I don't know if I should option. What's the word I'm looking for? scenario. That's the word. Scenario A. B and C share a common base. In that situation, and I will talk about what common bases are in a moment. In the situation where B and C share a common base, you want to rewrite the exponentials so they are both the same base, and then set the exponents equal to one another. I'm gonna call it scenario 1. You know what? Scenario 1. So you're going to rewrite these both sides with the common base. Oh no. That would be so frustrating to me if I was teaching and like my animal turns the computer off. That would be so frustrating. Kat was like, I think you're done here. I think we're done. All right. So the goal is to rewrite you're done. You're done. Words. Give me a moment. Rewriting them with the common base. That's what I was saying. So now that they both have the same base, common base, then you set the exponents equal to one another and solve. So you're setting the exponents equal. So like whatever was the exponent on the left side, you'll set equal to whatever the exponent was on the right side. And I can't draw a triangle. Good enough. Okay, so that's where B and C share a common base. Scenario 2, they don't share a common base. Oh, I just got the spam mail. Oh. So our department chair just got like somebody like tried to be him and sent an email to our entire department. It says, I have a request I need you to do discreetly. I'm going into a meeting soon. No calls, just reply to my email. And it's like an external email from a random Gmail number, random Gmail address. Like, oh, that's not suspicious at all. That's not a suspicious. It wasn't from my department chair, to be very clear. It's just a spam email. But that is a super suspicious sounding email. I do agree that it is it should have set that email should set off warning bells. All right, so if B and C don't share a common base, what you end up doing is applying ln to both sides and bringing down the exponents. So when applying ln to both sides, right, it looks like this. And you're going to bring down the exponent. Well, I'll just make that into another line. 2, bring down exponent and solve. So bringing down that exponent out front, you end up with something like this times ln b is equal to whatever the exponent was for the other side times ln c. All right. These are mostly for your future reference, all right, because you're still going to need to see each of these in action in order to understand it. So there's 2 scenarios. There's a scenario where your bases share a common base, and there's the situation where they don't share a common base. We're going to do both types of situations. In order to do these, though, we need to talk about like what in the world do you mean by a common base? So let me talk about common base families. Let's round that. Common base families. Two numbers share a common base if they're both powers of the same number. So for instance, 2 to the first power is 2, 2 squared is 4, 2 cubed is 8, 2 to the fourth is 16, 2 to the fifth is 32, and that's probably as far as I need to go. So 2, 4, 8, 16, and 32, those are all in the same common base family. They all share a common base because they're all powers of 2. They're all powers of 2. Three to the first power is 3, 3 squared is 9, 3 cubed is 27, 3 to the fourth power is 81, and 3 to the fifth power is 243. 3, 9, 27, 81, and 243 are all part of the same common base family. Oh no, I just wanted to make it not look side, but whatever. That's fine. 4 to the first power is 4, 4 squared is 16. Let's see, I'll go up to 4 to the fourth. 4 cubed is 64, and 4 to the fourth power is 256. 5 to the first power is 5, 5 squared is 25, and then 5 cubed is 125. So I'm not writing out all of these. It's just oftentimes when you're doing problems that have common bases, they're typically powers of 2 or 3. Sometimes they're powers of 4 and 5. Sometimes they're 6 and 7. But these are really the common ones that you're going to see when you're looking for common bases. So those are the common base families. So let's do some examples. Let's do some examples. Okay. Here, the first question we should ask ourselves first, is it in the correct form that needs to be simplified to? And by that I mean, is it in this form? Something raised to an exponent equals something raised to an exponent. And the answer is yes. Something raised to an exponent, something raised to an exponent. It is also fine, maybe I should put that up here. It is also fine for it to be b raised to something is just equal to a number. Right. So it might not be that there's an exponent on one of the sides. It could be that it's something raised to an exponent equals just a number. but you want it to look like one of these things. What you don't want is something like +7 out here. You don't want something being added or subtracted outside of those bases. Anyways, it's in the correct form. It's in the base raised to an exponent, base raised to an exponent. The next question we ask ourselves is, are 8 and 32 in the same common base family? Do they exist in the same in any common base family together? To which the answer is yes. 8 and 32 are both powers of 2. Because they share a common base, we're going to rewrite each of them with the common base and then set the exponents equal. In particular, I know that 8 is equal to 2 cubed and 32 is equal to 2 raised to the 5th power. Okay. So instead of 8, I'm going to write 2 cubed. So this is 2 cubed raised to the 3x minus 1. And instead of 32, I'm going to write 2 to the 5th raised to the x. So a little bit of color coding here, right? 8 is equal to 2 cubed. So this 8 here got replaced with 2 cubed. $32 is equal to 2 to the 5th. So this 32 got replaced with 2 to the 5th. It's just a direct replacement. Next thing, we need to remember an exponent rule. If you have x to the a raised to the b, this is where you multiplied those exponents together, all right? So over here, we have 3 multiplied by 3x minus 1. So we need to distribute this 3 because we are multiplying the exponents together. You end up with 2 raised to the 9x minus 3. And then here you're multiplying 5 and x together, which gives you 5x. So 2 raised to the 9x minus 3 is equal to 2 raised to the 5x. They now have a common base. They're both base 2, which means we can set the exponents equal. So I am taking this exponent and this exponent, and we're just going to set them equal and solve. So 9x minus 3 is equal to 5x. Subtracting 9x on both sides, we have -3 is equal to -4x. Dividing both sides by -4, we're going to get 3/4 is equal to x, which I will just rewrite as x equals 3/4. Once again, I want to repeat what these steps were here. First things first, I made sure it was written as base exponent equals base exponent. It came that way. Then I asked myself the question, are 8 and 32, do they share a common base? Do 8 and 32 share a common base? And they are in the same common base family right here. 8 and 32 are. So the answer was yes. So we rewrote 8 and 32 as powers of 2. Then we simplified their exponents using this exponent rule. Then we set the exponents equal to one another and solved like we solve any linear equation. Can I answer any questions on that problem? We're going to do more. Don't you worry, but just make sure. Just buffering. That's okay. Me too. My brain all day today. I am just buffering. Okay. So we have 7 raised to the x plus 1 plus 5 is equal to 50. I was actually going to do a different problem here, which is fine. I don't need to, but I'm going to add something in here real quick. Give me a sec. I have to decide what I'm going to do. So you don't have to rewrite the whole problem. That'll be fine, right? Yeah, that'll be fine. Okay. So just make sure you have this 9 out front. 9 times 7x plus 1, 7 raised to the x plus 1 plus 5 is equal to 50. We need to get it in the form of a base raised to an exponent is equal to either a base raised to an exponent or a number. We basically need to get the 7x plus 1 by itself is the goal, right? Getting the 7x plus 1 by itself is the goal here. Here is a word of caution. You may be tempted right now to be like 9 times 7 is 63, which is a correct statement. 9 times 7 is indeed 63. However, we cannot multiply these guys together, all right? We cannot multiply 9 and 7 because 7 is trapped with an exponent. This exponent is attached to 7 and 7 alone. And because he has an exponent on him, he cannot combine with the 9. So 9 times 7 raised to the x plus 1 plus 5 equals 50. To get that 7 by itself, normally I'm trying to show less and less of the algebra, but with this one I'm going to be a little more explicit with the algebra. You're going to start by, just like you would solve like a linear equation, you'll start by moving any constants over using addition or subtraction. So subtracting 5 on both sides to cancel out the 5 leaves you with 9 times 7 raised to the x plus 1. 50 minus 5 is 45. Then to get rid of the 9, you're dividing both sides by 9. So you have 7 raised to the x plus 1 is equal to 45 divided by 9 is going to be 5. These guys do not share a common base. They are not, 7 and 5 are not in any family together. They are not powers of the same number. We cannot use the method that we used in the previous problem. So because 7 and 5 do not have a common base, we are in scenario 2. Let me scroll up here. We're in scenario 2. In that case, we're applying ln to both sides and bringing the exponents down and then solving. Right, so I am applying ln to both sides. ln of 7 raised to the x plus 1 is going to be equal to ln of 5. We are applying ln on both sides. Now, here's just kind of a quick note. So when I was in college, when I was taking calculus in college, I spent a lot of time at our school's tutoring center, and we were doing something kind of related to this, right? But essentially what I was doing, my tutor was helping me, and I was like, all right, so then we want to do the ln on both sides, and I did it like this. And he was like, you can't do it like that. He's like, you can't write the ln afterwards. And I was like, and don't write this down, by the way, don't write this down. I was like, but I know what I mean. And so it's fine. I know what I mean. And he was like, I don't care if you know what you mean. You cannot write it like that. And I just kind of like, I mean, it obviously stuck with me. Obviously, this memory stuck with me for many, many years at this point. But I was like, you don't know what you're talking about. I know what I'm talking about. Silly math tutor. Now looking back on that, I look back and I'm like, oh, he was right. You cannot write it like this. I know I'm not looking at your work. I know that there's no consequences for it, but just know that you are building bad math karma if you write it like this. The ln comes, it's like ln of something. That's how it's written. Doing it like this is the math, it's like the equivalent of, instead of writing square root of 4, it would be like writing 4 square root and saying, I know what that means. Don't worry about it. Don't worry about it. It's fine. I understand that this means square root of 4, when clearly like this doesn't mean square root of 4. So the ln really, it needs to go before the number. You cannot put the ln after the number. That's not how ln works. Thank you for coming to my TED Talk. So, math TED Talk. That now that that's out of the way, with logarithms, we can bring down the exponent out front. Mic drop. We can bring down this exponent out front. When I do that, I have, oops, not 7. I have x plus 1, and I have it in parentheses, times ln 7 is equal to ln 5. Let me do a little highlighting and then double check that you guys understand what happened. So we got to here, we applied ln to both sides, and then I used our logarithm rule, the logarithm rule that we have says that if you have ln of x raised to the c, that this is c ln x. It's that rule there that says you can bring the exponent up or you can bring the exponent down. So I brought that exponent down and I have it in parentheses. It's really, really important that you do. All right. Exponents, if there's more than one part of the exponent, you need to bring it down with parentheses. We want to get x by itself now. What we're going to do is we're going to take this ln7 and we're going to distribute it. So we have x ln7 plus ln7 is equal to ln5. I'd also like to point out here that there's nothing special about ln. You could use log here. In fact, you could use log base 7. You could use any logarithm base, but ln is typically the one we use because there's less pen strokes involved in writing ln versus log. ln is 2 pen strokes, log is 3 pen strokes, and if it doesn't matter which one you use, you might as well use the one that uses less energy. So that's why we typically use ln's, is because it uses less energy than writing out the word log. So I've distributed the ln to both of these. I want to get x by itself. And the pattern we're going to be following for all the problems we do today that are like this are put the x terms on the left, put anything without x on the right, factor out an x, divide by the leftovers. Let me write that down. Now, you're going to notice this procedure is very similar to when we did inverse functions. There was like this very special type of inverse function, something like if you had one of these ones and you had to do an inverse on it, there was a very special algorithm that we used, and you're going to find out that this algorithm is very similar. So we're moving anything with an x to the left. So this guy's on the left, he stays here. Anything that doesn't have an x in it moves to the right. So we are subtracting ln7 on both sides. And canceling. So we have x ln7 is equal to ln5 minus ln7. There's no factoring out to do in this particular problem because we only have one x term, but we will get to problems that we have multiple. So we're good here, one x term. We just need to divide out the ln7 so that we can get x by itself. So when we do that, we cancel. And our answer is x is equal to ln5 minus ln7, all divided by ln7. So again, there wasn't any factoring to do on this problem. The next problem I do, there will be factoring. You're going to get a lot of messy looking answers like this. right? There's going to be a lot of messy answers. The way that Math Lab is going to work, it's going to ask you first for the exact answer. This is the exact answer, right? This is the exact answer. It's then going to ask you, for an approximation. So there's a question, unless I miss something, we leave the denominator alone. Yes, you just leave it exactly like this. You'll enter it exactly like that. And you'll just, complete answer right there. MyLab is also going to ask you for an approximation on these, which means you're going to need to know how to use your calculator. It's really important to know how to use your calculator. I have a student who, let's see. Oh, yeah. So I can see where that question comes from. So you're asking, like, can I cancel these? I think is what's then the question, like, right. So the answer, yeah. Okay, I see what you're saying. So we can only cancel it if each of them had an ln7 in it. So when you're canceling, you have to cancel for, like, each thing up here has to have something in it in order for it to cancel. You can't just cancel one of these, you would have to cancel it with both. So it's sort of like if you have 5x plus 7 all over x, you can't cancel those x's out. But if you had 5x plus 7x over x, then you could cancel all the x's out. So you can make it, you could split it basically into two separate fractions, and then the x's would cancel. So you'd have 5 plus 7. So you couldn't do it there. Like this one, you couldn't do it, but you could do it if they both had x's. Does that help a little bit? Excellent, excellent. With the approximation on these guys, if you're trying to use like an online calculator, like if you haven't purchased a calculator and you've been just kind of like using an online calculator to do your like computation type stuff, you're going to have to be really, really careful with your syntax, or you're going to get the wrong approximations, and it's going to drive you crazy. Highly suggest buying this calculator that I mentioned the first day of class. I feel very passionately about this calculator, the Casio FX 991EX. I know it's the end of the semester now, and you might not feel the necessity to buy a calculator, but if you're moving on in math anyway, you might as well have a nice calculator. This one's less than $20. It's a really good one. It's an amazing calculator. Highly suggest it. It makes entering this really easy because you just enter it exactly how it looks on the paper. You don't have to put extra parentheses in or anything. If you have a calculator in front of you and you want to double check that you know that you're entering things correctly, I will tell you what this approximation comes out to. And I don't remember if they want 2 or 3 decimals. It doesn't matter. But the approximation, if we did 3 decimals, would be negative 0.173. It actually comes out to 29, but you would round it up to 3. So if you want to practice putting that in your calculator, see if you get the same thing. But all the problems are going to basically ask for the exact answer, and then they're going to ask for the approximation. And that's something to kind of watch out for. And I'm going to start writing down this next problem. Also want to see something cool. Oh, it totally didn't understand what I said. That did not work out well. Man, I was all excited. I was like, look, I got this new feature on Notability where you can change text into math. Whoa. Crazy. I know, right? It's super neat. You have to pay for it, but I'm using the free trial right now. Okay. All right, so here we have something like 3 raised to the x plus 6 equals 5 raised to the 2x minus 1. You're going to see these on your homework. You need to know how to deal with them. It's the exact same process as we went through up here, except for instead of having an exponent only on one side, it's on both. Right? The whole story on exponential equations, take the ln of both sides, bring down the exponent, solve for x. So we're starting by taking the natural log of both sides. So ln of 3 raised to the x plus 6 is equal to ln of 5 raised to the 2x minus 1. So taking the ln of both sides. Next step is taking that exponent and bringing her on down. When you bring down the exponent, parentheses are important. On both sides, you are taking the ln and you are distributing it to all of the terms. So you have x ln 3 plus 6 ln 3 is equal to 2x ln 5 minus ln 5. I do suggest on these ones omitting like you'll notice I've omitted the parentheses on the ln. It makes it a lot faster if you only have a single number in there, you don't need the parentheses, so it makes it faster to omit those parentheses. All right. We need all the x terms on the left. Anything without x goes to the right. So this guy here, he's good to stay. He has an x in him and he's on the left, so that's fine. This one does not have an x in it, so it needs to move to the right side. So we would be subtracting 6 ln 3 on both sides, which would cancel this out. This guy has an x in him, so he needs to move to the other side. So we are subtracting 2x ln 5. What you're left with is x ln 3 minus 2x ln 5 is equal to negative ln 5 minus 6 ln 3. I want you to take a moment and make sure that you agree and understand what's happening here. Essentially, you want this guy on the left, but he's already there. You want this one on the left, and he has to move. So we would subtract him on both sides. You want this one on the right, which means he needs to move over because he's on the left right now. And you want this one on the right, and he's in the right spot. The right spot. So we subtracted the 6 ln 3, and then we also subtracted the 2x ln 5. Are there any questions about the math up to this point right here? Okay. You're going to pull out. It's okay. It's the algebra. It's tedious, but you're going to be okay. I promise. We're almost done. I believe in all of you. We pull that x out, and we have ln 3 minus 2 ln 5 equal to negative ln 5 minus 6 ln 3. So when I said to divide by the leftovers back in this, like if I scroll up here, divide by the leftovers, what I mean by the leftovers is this thing here. This right here is what I would call the leftovers. And maybe I'll just label that for us. This right here, the leftovers. We want to divide both sides by that. And that will give us x by itself. So I am dividing this side by ln3 minus 2 ln5. And I am dividing the other side by ln3 minus 2 ln5. So they cancel over here. And what's canceling? So just so I'm very, very clear here, it's canceling because it's an entire factor. The entire factor cancels. We could not just cancel ln3 and then 2 ln5. We don't cancel individually like that. It's that the entire factor cancels. What we're left with is x equal to negative ln5 minus 6 ln3 all over ln3 minus 2 ln5. And that is the answer. This is the exact answer. And you're going to find that some of these answers, like I said, are just kind of messy. They're just a tiny bit on the messier side. But I think they're kind of fun in that respect too, because then like you have a really fancy looking answer, and you can feel smart, you know, which is great. Right. I'm going to give you a moment, unless we're ready to move on. Are we ready to move on? Do we need a moment? Absolutely. That's why they're recorded. Absolutely. Okay. Twelve raised to the x minus 2 plus 7 is equal to 5. 12 raised to the x minus 2 plus 7 is equal to 5. We need to get it so that it's the 12 raised to the x minus 2 is by itself. So we are subtracting that 7 to begin with. And we get 12 raised to the x minus 2 is equal to negative 2. It's equal to negative 2. We're good to take the ln of both sides, right? It's base raised to a power equals a number. That means we're good. We can take the ln. Well, let's do it. So ln of 12 raised to the x minus 2 is equal to ln of negative 2. Here's where we sit and we ponder a little bit. Is there anything wrong with this situation? Is there anything peculiar? The negative 2 is peculiar. I would agree. I would agree. Can we have negatives on the inside of a logarithm? All of it's peculiar. Can we have negatives on the inside? No, we cannot. We cannot have a negative on the inside of a logarithm. That's a problem. He's not invited. Correct. He is not invited to the party. And this is actually a huge issue. We just don't have a solution here. Like it's over. It's all over. There's just no solution. Yes, you do. You want to be invited to you want to be invited to the logarithm party. He did. He literally crashed the party. He ruined everything. -2 said, I'm done. I'm out. There's no solution to this. I'm gone. And then we end up with no solution. So just something to look out for. Make sure that you're not being too mindless in your work, because if you're being mindless in your work, you may get to this step here and not think anything of it. And then you would, you'd be like, all right, now I have x minus 2, ln 12 is equal to ln -2. And then, x ln 12. And you could get the whole answer. He was too negative. That's a good one. He was too negative. Just be mindful in looking for negatives inside of logarithms. All right, that's all I'm trying to say, because you could easily have gone forward in this problem, entered your answer in, and been like, why is it not right? Because you could have done the math all right and just not recognized that you took ln of a negative number. So I want to just mention that. All right, 8 minus 5 e raised to the x plus 2 is equal to 2. 8 minus 5 e raised to the x plus 2 is equal to 2. Our goal is going to be to get this e raised to the x plus 2 by itself. I don't like the way the highlighting looked there, but we want to get this e raised to the x plus 2 by itself. What if a number had a negative in front? So which number? Ah, that was a strange noise. So if you have -12 raised to the x minus 2, if there's no parentheses here, it actually means that the negative isn't attached to the base at all. But if you had this, where it was like explicitly in the base, you wouldn't have that, because we can't have that. You're not going to end up with a problem that does that. Does that make sense? So if you do have a negative out front, it's not actually attached to the, yeah. That's actually an excellent question, and I kind of wish I had just made that a minus e to the x plus 2 now. Too late to change my mind. But excellent question. So I'll just leave that there, just in case you want to look at it. So I'm trying to get e by itself. I am starting with subtracting 8 on both sides. I'm left with -5 e raised to the x plus 2 is equal to -6. Still working on getting that e by itself. So I'm not subtracting. I am dividing by -5 on both sides, because that will cancel the -5 in front of the e. I get e raised to the x plus 2 is equal to 6 divided by 5. Now that we have the base by itself, the base and the exponent by itself, equal to a number, we can take the natural log of both sides. ln. And everything is okay here. This problem does have an answer. However, you're going to get simplification problems if you aren't careful. Remember that we have a rule that says ln of e to the x is equal to x, right? That the ln e just kind of cancel themselves out. And this works for whatever you have in the exponent here. The ln e really just kind of cancels and you're left with just the x plus 2. You don't have to bring down the exponent at all. It just kind of, it just kind of falls down. Once you do the cancellation, it just falls on down. Is equal to ln of 6 divided by 5. And to get that x by itself, you are just subtracting 2 on both sides, which gives you x equal to ln of 6/5 minus 2. Can I answer any questions on that example? I'm just going to scroll up real quick. I want to see, can't remember if I did a particular example. Okay, I didn't do that one. So my thought process on what's going to probably be the most difficult on this homework is going to be problems like this one here, right? This guy who's a little bit on the messier side. So what I would like to do is give you one that is similar to this and have you kind of work through it, and I'll work through it as well. But that would allow you some practice right now in a safe environment. Low stakes. So I want you to give this one a try. 11 raised to the 6x plus 5 is equal to 2 raised to the 3x. This is going to be, you apply a logarithm, apply ln to both sides, and then bring down the exponents and solve like we've done the previous problems. I'd like for you to try working through this on your own. I'm going to give you like a minute head start, and then I'll start writing down the answer so you can check your work if you get stuck. At least one person is done. I am nearly done writing the answer out. I'm being a cheater, pumpkin eater over here. And I have that final answer up there for you. Now, hopefully that went well. How's it going? How is it going? Excellent. That's great news. That's excellent. Because it doesn't matter which side you select the X's on and which side you put the rest of the stuff on, you may get an answer that looks slightly different than this, but is also 100% correct. So if you had, instead of putting the X's on the left, if you put the X's on the right and everything else on the left, you may have got the answer 5 ln 11 all over 3 ln 2 minus 6 ln 11. And this would actually be the same exact answer. And it would be correct. So if you got that answer instead because you moved the X's to the other side, totally fine. It's correct. Or if you got this answer, correct. So this one will take practice. Yep, MyLab will absolutely accept both, 100%. Yes, it's one of those times where I feel confident saying absolutely. Okay, so that is all I have for you for exponential equations. You now can do everything in part 1 of the homework. So you should definitely start that if you haven't already. I am basically done with the worksheet that I'm going to send out. It's like 9 pages long. I need to send it out soon. I'm just kind of messing around with a few things, but there is a worksheet for tomorrow. It is pretty long. Please print it if you have a chance. It'll really save you a ton of handwriting, and it'll allow us to get through quite a bit more. So look out for that worksheet. It'll be out soon. I think that's all I have to say. Any questions? No. Do you have a tablet? Do you have an iPad? If not, just at least look at what. Okay, yeah. I'm gonna try to get it out soon. I will try to get it out soon. Like I said, there's just a few things left to change. All right. Happy Tuesday, everybody. If you have questions, send me an email. Otherwise, I will see you all tomorrow. And I'll turn off the recording. Bye.